Hello and welcome to the virtual Kansas City SQL Server user group. Thanks everyone for joining. We are happy to welcome Dennis Torres to our user group today, presenting SQL Server 2022 Intelligent Query Processing New Features. Thank you again for presenting this for us today. I know I haven't really played around with 2022 very much of late, so I'm excited for this presentation. Thank you today. For our audience, this session is recorded and will be uploaded to our YouTube channel. If you have any questions, go ahead and pop them in the chat, and then at appropriate times, I'll go ahead and ask in person. And with that, I'm going to let you take it away, Dennis.
Thank you, Christina. Welcome, everyone. Thank you very much for attending this session. I'll be talking about SQL Server 2022 Intelligence Query Processing new features. These features I'm talking about, Intelligent Query Processing, were first introduced in SQL Server 2022, but they are a result of an evolution that comes in SQL Server 2016. Let's talk a bit about this. But first, this is me. My name is Dennis Torres. I'm a former data platform MVP. I was MVP from 2020 to 2023. I'm a trainer. I'm the multi-data platform user group leader. And you can see on the right side of the screen my contacts, especially the social media contacts. It will be a pleasure to stay in touch on LinkedIn, YouTube. If you'd like to send any questions about this session or any subject, feel free to send to me, no problem. So, let's start. These features that I'll be talking about, they are the evolution of features that started appearing in SQL Server 2016. So let's understand how they appeared, how they evolved to understand their current status today. I'll be talking about query store hints. I'll be talking about DOP feedback and C feedback. So these are the three main features that I'll be talking about. So like Carl Sagan usually says, you have to know the past to understand the present. And in fact, this is very true in relation to the current SQL Server features, the current intelligence query processing features. If you try to understand them, let's say, directly, without studying how they appeared in past versions, it would be very difficult. We need to understand the evolution since SQL Server 2016 to today. So, before SQL Server 2016, it was very difficult to answer some questions. For example, if a user came to us and asked, oh, my query is sometimes slow, sometimes not. My query was slow in the morning, but it's okay now. This was extremely difficult to answer before SQL Server 2016 because we only had the current queries executing in the query plan cache. The query plan cache was caching the current query plans for each query. So if the query was slow and it's not anymore, probably the query plan has changed between this time. And we can see what query plan was being used before and why it changed. It was very difficult to identify something like that. Also, our start on the service or the server would completely clear the cache of query plans. We would not know the query plan the query was using anymore. There was no history of query plans. No one was thinking about that. Even thinking about that, it was just a challenge. Then it comes SQL Server 2016. SQL Server 2016 brought a great new feature that became the foundation of lots of new resources for query optimization. This feature is the query store. So from SQL Server 2016, SQL Server started to store a history of the queries and query plans being executed. It was not only the plan cache, it was not only about caching the plan, it was about registering a history that in the morning this query was executing with this one specific query plan. Then in the afternoon the query plan changed. The same query was executing with a new query plan. It was about registering a history of the query plans used by the query. So queries and plan history. And registering this history, this also helped us to register and to identify what started to be called a query plan regression. The query store was not only registering the query plans that the queries were using, but it was also registering performance metrics for the executions of those query plans. So it was registering performance metrics for one query plan the query was using. Then if the query plan changed, it started registering the metrics for the new query plan the query was using. Then a new concept was appearing, the concept of plan regression. What is it, plan regression? Plan regression is when a query changes its query plan for some reason. Many reasons can force a query to be recompiled and result in a new plan. Maybe an index changed, maybe the amount of data changed, and so on. Many reasons could make a query change its plan. But it's also possible that the new plan of the query is not better than the older one, is worse than the older one. And that's the situation that started to be called query plan regression. When the query gets a new query plan and this new query plan is worse than the previous query plan that we had. And using query store, we could identify query plan regressions. This became something possible, something that we were not even thinking about before 2016. And it became easier to establish baselines. Some documentations even recommend this kind of technique to establish baselines in relation to SQL Server. For example, you are about to make a change in your database. You are about to make a change in your database, and you are not sure if your change will make things better or make things worse. So what you do? You need to have Query Store enabled. Let Query Store collect information from your database. Let Query Store collect information from your database if it is already not collecting this information. Then you make the change and Query Store will continue collecting information after the change. So what will happen? The change may result in changes in the query execution time and may cause query plan regressions. So you can identify if a change made in a database caused any kind of regression, any kind of change to worse, or if it improved the database itself. Um, it was very good to have a way to identify that. It's like an easy way to establish a baseline for our database and then compare the database behavior after changes with that baseline. It's also a good way to ask for a raise, a salary increase, for example, because you could prove the results you were creating from your database. You could prove the improvements of the database. So we also could identify parameter sniffing, but not solve it yet. Parameter sniffing is always a huge challenge. I wrote many articles about this, and query store, by storing the execution time of the queries of the query plans, allows us to identify situations with parameter sniffing. What is a parameter sniffing problem? Parameter sniffing problem, I'll try to summarize that, is basically when a query is parameterized, but the values of the parameter in the table, they are not very well distributed. For some values of that parameter, there are 1, 2, 10 records. For other values, there are thousands of records. So in this case, the query is parameterized, intending to have one single query plan. But depending on the value which arrives, the query plan should be different. The query plan should be one for values that result in only a few records, and a different one for values that result in a huge amount of records. This is a problem we usually call parameter sniffing, and it's very difficult to solve. The solution, in fact, a very good and better solution only appeared in SQL Server 2022. On SQL Server 2017, uh, a new query optimization feature was created. It started to be called adaptive query processing. This brought many new features. Um, the cache, the query plan cache was not immutable anymore, and this was a great feature. This was a great feature. This was meaning that the query plan cache could have queries that would sometimes behave in one way, sometimes behave in another way. The adaptive query processing. Uh, the first feedback was created. What is a feedback? A feedback is when SQL Server starts analyzing your query, analyze the needs of your query, and decides this query should process with different parameters with different resources. So the first feedback feature was created in 2017, and it is the memory grant feedback. The SQL Server started to analyze the amount of memory granted for each query. Uh, if the amount of memory granted for each query was too small, this would cause spills. For example, TempDB spills, and data would be processed inside TempDB because there was not enough memory allocated to the query. This would make the query terribly slow. So, this memory grant feedback, which was first created in 2017, was capable to identify this immediately and change that query automatically. What do I mean? It was capable to identify that a query was causing spills because the amount of memory for that query was too small. Then it hashed a feedback by changing the plan for that query and forcing the plan for that query on the further executions to allocate more memory to that same query. So this is an idea of a feedback feature, analyzing the behavior of a query and changing the behavior of future execution of that query. And this one from 2017 was only the first feedback query which appeared. So parameter sniffing started to have a partial solution with some of these features. Uh, for example, we got adaptive joins. Adaptive joins were capable to make the join in one way or another according to the amount of records the query would return. A parameterized query using adaptive join would not suffer too much in relation to parameter sniffing. The memory grant feedback would adapt the amount of memory to situations of parameter sniffing, although you could imagine that it could have limitations. If you start to have every time to keep changing the amount of memory of the query, it would not work. So it had limitations. Uh, so the parameter sniffing started to get some solutions. But all these solutions were very focused on what is called batch mode. And because exactly of this, we started paying more attention to what was batch mode and what was row mode exactly. What was that? So we started to pay more attention for this in SQL Server 2017. And Quick Store got additional features allowing us to get recommendations to force some plans. Quick Store feature, since it was created in SQL Server 2016, was capable to allow us to force a plan. If you identify, for example, a query plan regression, oh, the plan of the query became worse. How do we solve that? Query store was capable to allow us to force a plan for the query. No, I want this query to use this plan that you have recorded in your history. It was an action of forcing a plan. And that query would use that plan that we force. From SQL Server 2017, Query Store started to give recommendations in relation to plan forcing. It started to identify the plan regression by itself. It identified the concept. It started to identify that it was happening. The plan regression was happening, and it's starting to tell us, oh, this query would work better if you force a regression, if you force a specific plan, forcing this query to work with this plan. So this started in 2017. I mentioned about batch mode. What's exactly batching mode? Batching mode is a processing method and is related to the kind of indexing and the storage that we are using. So we have batch mode as one processing method, and batch mode is linked to column store, indexes, and tables. If our table is using column store index, then the query over that table is working in batch mode. Usually the tables using column store index, or at least at that time, usually the tables using this kind of index were tables intended for data analysis. The hugest queries would be executed over these tables. And we had go mode. We still have them. We just started to pay attention to them around SQL Server 2017. So the row mode use the rows, what we call row store. Our regular clustered and non-clustered index are what is called row store. And the queries running over row store are a, a processing method called row mode. And what I mentioned before, in SQL Server 2017, most of the advantage were focused on batch mode. The features were made to run in batch mode, and row mode was not getting many of the advantage. This then changed with intelligent query processing in SQL Server 2019. In SQL Server 2019, it appeared to be a fancy new name. Yeah, maybe it was a fancy new name. The idea is it was to join many advances in a single name. The name Adaptive Query Processing that was created in SQL Server 2017 was not good enough in relation to all the improvements which were appearing in SQL Server 2019. So a fancy new name was created, Intelligence Query Processing. Batch mode, it was not a limitation anymore. Uh, it's not so simple, but the point, a bottom line of the point is that batch mode was not a limitation anymore. How batch mode was not a limitation anymore? Because some of the features that in previous versions were available only for batch mode started to be available for raw mode as well. For example, memory grant feedback. Memory grant feedback started to be available for raw mode in SQL Server 2019. And for features which were not available in raw mode yet, SQL Server 2019 brought a capability called batch mode over raw store. The query processing in SQL Server 2019 was capable to identify some queries as complex, heavy queries that would get benefits by running in batch mode. So even if your tables were in row store, even if your tables had no column store index, SQL Server 2019 was capable to turn the execution of that query in batch mode. And by turning the execution of that query in batch mode, that query would get all the benefits which were created for batch mode before. So things got mixed in SQL Server 2019 exactly to allow all the queries to get these benefits, not only batch mode queries to get these performance benefits, but all the queries to get these performance benefits. Now let's talk about SQL Server 2022. SQL Server 2022 is the first SQL Server version where Query Store is enabled by default. On our previous versions, since SQL Server 2016, enable Query Store was an option. On SQL Server 2022, Query Store is enabled by default. The option became disable Query Store if for some reason you don't want to use it. But at this point of the evolution, a lot of query optimization features were relying on Query Store. If you disable Query Store, you lose all of them. So we got a feature called Query Store Hints. What's that? Well, you know about query hints. We can make optimization on queries using query hints. Oh, that query is not performing very well, but if you use that query with a specific query hint, that query would perform better. But how would you make this change before? To use a query with a query hint, you need to change the source application. You need to go into the code of the source application and ask the developer to apply that query hint on the code of the source application to send that query with that query hint that would make the query perform better. But in SQL Server 2022, we got a new feature called Query Store Hints. Query Store Query Hints. What this means? This means that Query Store is registering all the queries that are being executed in the database. If we notice that one of these queries would benefit in some way for a specific query hint, we can apply query hint on the server level. So for the first time, we could apply a query hint without changing the source application. Without making any change to the source application, we could apply a query hint to a specific query. Otherwise, the task in a company to ask the developer to change the source application is not something easy. Is not something easy to execute. And this feature in SQL Server 2022 changed that. Um, it's more than a single feature in a single version of SQL Server. It was a changing, a shift on the way things were working. The quick store hints were a big sign of that. Why? Because Microsoft at this point was already applying an idea of cloud first. Query store query hint. This feature appeared in Azure SQL Database in the cloud 6 months before the release of SQL Server 2022. 6 months before we could see this feature in SQL Server 2022, we had this feature in Azure SQL Cloud, Azure SQL Database. So Microsoft was already applying the idea of cloud first when implementing these performance features. Feedbacks started to be persisted. And I'm talking feedbacks in the plural because until now we talked about one single feedback. We talked about the memory grant feedback, but especially in SQL Server 2022, it became a plural, many feedbacks. Your queries started to receive many different kinds of feedback. And these feedbacks started to be persisted. What this means? This means that before the feedbacks were something kept in memory, in caches, and if you restart the service, the feedbacks would be lost. This started to increase the damage of restarting the service because the feedbacks would be lost. But see, the feedbacks started to be persisted. Persisted where? Tables belonging to Query Store. Query Store got new tables which became responsible to persist the feedbacks. Feedbacks like memory grant feedbacks, for example. So they started to be persisted. So you could restart the service and the service would come back online with the feedback available, with the feedback being used by your system. So you would not lose your feedbacks, your query feedbacks after a restart of the system. The workflow of the query processor changed. What do I mean about the workflow of the query processor changed? This is something that you can notice if you look very closely to the new feedback features. Because when a query is processed, there is, SQL Server 2022 started to make an analysis of that query in relation to the feedbacks, in relation if there was some feedback applied to that query, in relation to if there was some query hint applied to that query. This means that the sequence of processing of a query changed. When a query arrives, the query processor would look to query store first. For example, query store hint. The query processor would need to look for the query store hint to check if there is any hint that needs to be applied to that query. It would need to look to the feedbacks stored in Query Store to check if there is any feedback which needs to be applied to this query. So the workflow of the query processor changed in SQL Server 2022. And feedbacks appeared all around. All around. I will give many examples. And the interesting point of the feedbacks is that the feedbacks rely on the query store history. The query store history provides a history of how is the execution of this query behaving. Is that execution getting better? Is that execution getting worse? Even if the query doesn't change from one plan to another, the query processor can still analyze the history of execution of that query and discover if that query is getting better or getting worse. And the feedbacks appear all around and depending on query store history. Parameters if got finally solved or very close to solved, it becomes something way more difficult to happen because the new features in SQL Server 2022. Let's start talking about these new features. First, let's start talking about query store hints. Is the idea that we can apply a hint in a query store query. The query store is recording the history of the queries. We can check the history of these queries and apply a hint for a query located inside query store. We can adjust the query performance with no code change, what I was talking about. We can apply a hint to a query to adjust the query performance without the need to change the source application. The hint is persisted. It's persisted inside the query store. Query processor honor the hint. What I mean before about how the query processor workflow changed. When a query arrives to the server, query processor takes a look on query store to check the hints stored there and apply the hint to the queries. The workflow of the query processor changed. And we have the query store data to follow up the results. So once we apply a hint, we can check the execution data inside query store to check if the hint really provided a better result, improved the query, or no, if the result was not so good, and we should change that hint. Let's see a demonstration about how these work, how query store hints work. I have here a virtual machine with SQL Server 2022. Let me get a sample script. So this script is using AdventureWorks 2019. There is a stop procedure, filter price, and an index in a table big product. This table big product is produced by a script, a very old script called make big adventure. This script creates a huge table in AdventureWorks, which we can use for examples. Let's create a stop procedure, filter price. This stop procedure receives a list price, which is a numeric value, and makes a query. Don't do like I'm doing. This is just a small example, okay? Don't use the style like I'm doing. So from big product, it filters the list price. So I'm creating the stop procedure, creating an index over list price. List price is not the best field for that, but again, is just an example to illustrate the effect of a query hint, a query store hint. Let's see the distribution of the list price. So we may notice here that uh, there are lots of records with the list price 0, 10,000 records with the list price 0. While I have another list price here, 121.49. 121.49 is somewhere here around 50 records. So this is what I was talking about, an uneven data distribution in a column that we are filtering. So the same column, list price, if I'm using one value as a parameter for a query, this query would return only 50 records. If I use a different value as a parameter for the same query, this query would return 10,000 records. So it's a completely uneven distribution. So let's see how this works. Let's execute this one, filter price. Sorry. Let's include the actual execution plan to gather the execution. And I'm using a wizard compile to be sure that I'm seeing the plan that we would really be the best one for this query. And the best one for this value with this stop procedure is this plan using an index seek and the key lookup. Because the amount of rows returned is very small. If the amount of rows returned is very small, the key lookup is not perfect. It's not something that we like to see in a query plan, but the amount of rows returned is small, so it's not too bad. Uh, while for the other one, for the 0, the amount of key lookups that would be executed would be huge. That's why the 0 can't use an index seek. The 0 needs to use an index scan in this situation. So for one value, the query plan needs to be 1. For another value, the query plan needs to be another. The procedure is the same, the query is the same, but it requires different query plans according to the value. This is exactly the example I was mentioning as parameter sniffing, a parameter sniffing problem. The value of the parameter affects the query plan that we should use. Let me clear the procedure cache and make a further illustration of the parameter sniffing problem. Let me execute both queries without the whistle compile. We will execute the first one. The first one will be executed with an index seek. But then what happens? What happens is that the first one was compiled and the compiled plan was stored in the query plan cache. In this way, the second one with a different value will reuse the plan from the query plan cache. And as a result, the second one is using index seek as well. This shouldn't happen. This shouldn't happen because we know that index seek is a terrible option for this query because it causes a huge amount of key lookups. Let's take a look here. 98% of the cost of this query was on the key lookup. The amount of key lookups this causes is huge. So it should not be using this query plan, but it is. It's how the parameter sniffing works. The first parameter, which is executed with the query, calls the query compilation, and the query will be compiled as the result of this first parameter. Then all following parameters will reuse that query plan, even if that query plan is not good for them. That's the problem. Now let me clear the procedure cache again. I'm clearing the procedure cache, but in no moment I'm clearing the query store cache. In no moment I'm clearing the query store cache. Let's check these queries inside query store. I'm looking inside assistant table from query store text, and joining with query store query to find the query over the table big product. I'm looking for this query inside the query store information. And I'm looking that I have two I believe the most recent one is this last one. Let me try. Probably I have two because I haven't fully prepared before the demo. I should have cleared the query store. I believe it's the second one. What I'm doing here, I'm using a store procedure sp query store set hints to set a hint. Which hint? A hint called option recompile for the query ID 154. So I'm using this query and I can check the query hints. The query 154 has the hint option recompile. Okay. Well, I had to choose one between two queries in query store. Let's see if I choose the correct one. Let's clear the procedure cache again. I'm clearing the query plan cache, but I'm not clearing query store. Query store has its history. So I will execute the first one again. Let's check the execution plan. Index seek and key lookup. And then I will execute the second one. Let's check again. Index scan. This time, the plan from the first query was not reused on the second query. Why the plan from the first query was not reused for the second query? Because I applied the query hint. Which was option recompiled. So this query is now using the option recompile as a query hint. So in this way, I improved the query with no need to change the source code related to this query. I had no need to change the source code, either the stop procedure. I had no need to change the stop procedure. Either this query could be sent from another application, an external application, and I had no need to change the external application. So I applied the hint, and the hint affected the result of the query. Okay. Let's get back to our slides. In this, we just saw an example about how the query store hint works. That's great. Now let's talk about DOP feedback. What do I mean about DOP feedback? DOP is degree of parallelism. Degree of parallelism of a query. What is a DOP feedback? The point is, what if a query is using parallel execution, but is using parallel execution in excess? Is too much for that query. and that query should not use that much. Or the opposite. What if the query is using the feedback but is too low? The DOP but is too low. We usually use the max DOP configuration, and we need to set the max DOP configuration on server level. Most recently, the max DOP configuration was available in database level. We could set the max DOP configuration on a database level. But what if SQL Server could analyze the perfect DOP value, max DOP value for each query according to execution? That's what SQL Server 2022 is capable to do. It's capable to analyze the queries using multiple cores, using parallel executions, and check if they have an ideal DOP value. If they don't have an ideal DOP value, SQL Server can analyze and test different DOP values to these queries. So, identify problems with queries running in parallel. Which kind of problems of queries running in parallel? Uh, when we have many threads, each one running pieces of the query, and some run fast and one is slower, for example. So this is a problem of queries running in parallel. So inefficiencies based on CPU time, elapsed time, and the weights, the query weight that are generated by the query. The DOP feedback feature analyze all that, analyze CPU time, elapsed time, the weight for the query, and in this way defines if the query may get better benefit using a better DOP value. It will lower the max DOP. So we have a max DOP specified on database level, and we have a max DOP specified on server level. Good DBAs always calculate this max DOP, but some DBAs in some environments don't calculate it, they just leave as zero. It means use all the cores that you want. And sometimes this is not so good for the queries. So the DOP feedback is capable to lower the max DOP on a query level. How? Using query hints. And to use the query hints, they are based on the query store hint feature that we just saw, that we can apply a query store hint over the query store. And then the feedback features started to rely on that feature because they can analyze if a query would perform better in a different way, and they can apply a query hint for those queries. The DOP feedback feature makes many evaluation cycles to stabilize the query and be sure the query is running well, is running stabilized after the feedback is provided. The ceiling is always the max DOP. The max DOP is specified for the server level or database level, or if the query already has a max DOP hint. If the query already has a max DOP hint, it will not be touched. It depends on the query store history. So if you turn off the query store, you lose this feature. If you turn off query store and you don't have this feature, this optimization feature. There is a query store table called sys query store plan feedbacks. This table is the query store table that holds the feedbacks. I mentioned before, the feedbacks started to be stored. started to be persistent. I can turn off the service, I can turn off the server, and the feedbacks are still there. Yes, in this table. It's well validated when the cache is cleared. So when we have clear plain cache, then the feedback is revalidated to be sure that the feedback is still valid. Feedback is applied from query store after clearing the cache, so we can clear the cache and the feedback is still applied, but it will pass by a new validation process. It can be enabled, disabled at database level. First, I said, if you disable query store, you completely lose this feature. That's a fact. But you have the option, if you don't want this feature to be used, you can completely disable this feature if you would like so. If you would like, you can completely disable the feedback. And it can be monitored using extended events. This feature uses extended events to explain what is happening, to show to us what is happening. So, this is an example of how the extended events can show the feedback happening. First is to identify an eligible query. A query is eligible to receive a feedback. Then it provides the feedback. In the past, I saw examples of 7 minutes between discovering that the query was eligible and providing the feedback. I saw examples of 7 minutes. In the past, recently I have saw way longer times. It varies a lot. Then it happens the validation cycle. There are multiple validation events to check if the query is really performing better after the feedback is provided. And the last event defines that the query is stable, is stabilized. The last event defines the query as stabilized. Then, after the cache is cleared, there is no identification of the eligible query. The feedback is provided from the stored feedbacks, is coming from the stored feedbacks, and the validation happens again. The validation process happens again. What's the DBA work in relation to this? In this case, this feature is doing all the DBA work in relation to optimization of the query. The DBA work becomes to investigate extended events and make conclusions in relation to the extended events and the application of the DOP feedback. If you have too many DOP feedbacks, this may mean that you have a bad max DOP configuration. If your server is generating too many of DOP feedback, you have a bad max DOP configuration. Too many DOP feedbacks setting the max DOP as the minimum possible, this means that you may have a bad configuration value for the cost threshold of parallelism. This means that queries that may not be executing in parallel, that should not be executing in parallel, they are in parallel because your configuration value for the cost threshold for parallelism is not good, is too low. So queries that should not use parallelism, they are using parallelism. And the best that the feedback can do for you is to set these queries to the minimum of parallelism possible. They will not disable parallelism on them, but they will set them to the minimum. And if you have too many situations where the queries are being set to the minimum, this means that you have a bad configuration of this guy. Or the opposite, if you have too many queries on the maximum possible DOP, which are being set as the maximum possible DOP, maybe the value, you have a configuration value for max DOP, but this configuration value for the max DOP is too low. And the queries are end up using the maximum value of this max DOP. Let's see an example. In fact, see an example of the DOP feedback is not something easy. It's not something easy. It requires to have a long execution to allow the system to process the feedback. That's why I did this outside the session and only left for the session the result of a live extended event session. A live extended event session which captured the event, query legible, feedback provided, validation, feedback provided, validation. So it identifies an eligible query. This query is eligible to be analyzed for the DOP feedback. Then it defines this feature to provide the feedback. And on the feedback provided, it defined the feedback. The current DOP of this query is 8. Then it decided to provide the feedback as 6, reducing the max DOP of this query to 6. Then it happens the validation, and the validation specifies what's the current state. It's still pending validation. So pending validation. And finally, the last validation points the query, okay, I consider this query now is stable. This query is stable, it's with a good enough DOP, but it doesn't mean it ends here. It can decide, no, this DOP is not good enough. Let's provide another feedback. So it provided another feedback and decided to reduce the DOP again, reduce the DOP from 6 to 4. It started on 8 and it reduced it to 6 and now decided to reduce to 4. And the validation again, pending validation, I stopped the execution of the batch before it reached a stable level. If the batch continues, the batch would continue run until the validation reaches a stable point for the new DOP, which is 4. This is executed over the worldwide importers, wide world importers. Let's make a select star from sys query store plan feedback. So I'm checking the feedbacks that I have available on the query store, and I can see that I have here a DOP feedback, there are some memory grants feedback, and there is a CE feedback, regressed CE feedback, that we will still talk about the CE feedback. Okay, so in this way we see an example about how the DOP feedback is applied. Let's get back to our PowerPoint. Let's talk about CE feedback. What do I mean about CE? CE, I mean about cardinality estimator. Cardinality estimator feedback. So We all may know that the cardinality estimator, when I talk about cardinality estimator, I'm talking about the SQL Server feature that calculates the number of rows that a query will return, the number of rows that a query will return before it is executed. And this number is essential to define the query plan. What does it mean, a C feedback? The point is that the cardinality estimator takes lots and lots of decisions when making this calculation of how many rows this query will return. While making these decisions, the cardinality estimator makes lots of very complex decisions about how to interpret the query. And these decisions may not be correct, may be wrong. And these decisions can be changed by a query hint. We can use a query hint to change the decisions of the cardinality estimator. This is something very advanced in relation to query optimization. But the point is, from SQL Server 2022, we have a feedback feature that makes this analysis for us, identifies if some decisions related to cardinality estimator are not good enough, and apply a hint to change the way the cardinality estimator is taking those decisions. So, see, we are talking about cardinality estimator. It's not about the estimation itself, not about the C itself, but about the techniques the C used to make the estimation, the decisions the C takes to make the estimation. And these decisions can be changed by query hints. And in this way, the feedback feature can identify if a decision is not being so good and decide to apply a query hint to change this kind of decision. So, in SQL Server 2022, at this point that I'm mentioning, there were three techniques implemented for the feedback. The feedback was analyzing three specific decisions that the cardinality estimator had to make. One is the predicate independence versus predicate correlation is one of the decisions that the CE needs to make, and it may be identified as not so good and may be changed. Another one is joint containment assumption, simple versus base, or row goal. Let's analyze these three. This is a complex subject in relation to CE. Predicate independence versus predicate correlation. Let's analyze this query. This query is made over the person address table. So we are filtering the state province ID 79 and city Redmond. So the cardinality estimator needs to decide if it will consider the two predicates, state, province, and city, as independent predicates or as full correlated predicates. For example, our record, our record that belongs to Redmond inside the state 79? Probably yes. Probably yes. Redmond is in one specific state, so city and the state is something that involves correlation. But in many other situations, we may have independent predicates. So there is the need to define if the calculation of the amount of rows that will be returned will be done considering the predicates independent or considering the predicates as full correlated. The default behavior for the CE is to consider independence. The CE doesn't consider correlation by default. It considers that the predicates are independent. Let's talk about joint containment, another decision that the cardinality estimator needs to make. Simple containment. When joint predicates are fully correlated. This means that there is a full correlation between the predicates of the join. We talked about correlation before. Then the cardinality estimator can estimate the filters first and later estimate the joins. Base containment. There are no correlation between the join predicates. In this case, the cardinality estimator makes the opposite calculation. Estimate the join first and then calculate the filters over the result. And each method of calculation will result in a different estimation of rows that will be returned. And if the estimation of rows that will be returned is wrong, it may result in a bad query plan. So this is a second method of cardinality estimator calculation that is considered for the feedback. And then we have the row goal. Row goal is when we have some specific elements in the query that define the amount of rows that will be returned. For example, it's applied to queries using top one queries with this join and this specific filter. How many rows the cardinality estimator imagines that will need to be returned to find one record with this criteria, supporting this criteria? Scanning a few pages is enough, or a seek is needed. So maybe it's better to scan just a few pages and find the row that is on this criteria, or maybe a seek is needed, and the cardinality estimator needs to decide that. Row is the default. It means that it will scan only a few pages in the case of a top one applied. A feedback can disable this and specify that it needs to make a seek. Let's see an example of this. These are very complex decisions made by the cardinality estimator. Let's see an example of this. I will not exemplify all of the three. I'll make an example of one of them. I'll be using the AdventWorks. I have an AdventWorks 2016 database. I have an extended event session. So let me close this. And I have an extended event session for CE feedback. Let me watch live data, open this session to watch live data. Here is the code to create this session. AdventWorks 2016. I'm already with the database selected. Let's clear the procedure cache, and I'm also clearing data on query store for this database. Here I'm also clearing query store. Then what I'm illustrating here is the predicate correlation. I'm making exactly the example from the PowerPoint related to predicate correlation. You state province ID 79 and city Redmond. I'm executing this and I'm asking the execution to be repeated 15 times. That's it. That's a magic number. When this magic number is reached and passed, the estimation feedback will be made. Okay. Let's check the feedback table and the query hints table. At the moment, they are empty. Empty. Let's make one more execution of this query. One more execution of this query. Now let's check again the feedback table and the query store hints. And now I have in the feedbacks table a C feedback. And this feedback is pending validation. I don't have a hint yet. It's about to actually persist the hint. It's validating to see if this C feedback is valid. Then I execute one more time and check again the result of the tables. And that is it. Multiple results could happen. It could decide that no, this feedback is not actually valid, let's regress it, and it would not apply the hint. But in this example, it decided no, this feedback is correct. This query needs this hint. This query needs this hint, and it made the application of the query hint for this query. It made the application of the query hint for this query. So this query now is using a simple index scan. Is using a simple index scan to read this data. It's using a simple index scan to read this data. I missed to show how the query plan was before. I'll need to get back to the beginning to illustrate that. Let's clear everything. The procedure cache and the query store. Let me execute this query again. Without the feedback, without the hint, it was making two index 6, a lookup, a merge, join, nested loop, and join the information. This was the default behavior of the cardinality estimator, the default conclusion of the cardinality estimator. Okay, then at this moment, after executing 15 times, I don't have anything yet. Then I execute once again. Then I have the application for the feedback pending validation. When I execute one more time and check the result, the hint is persisted. The query store hint is persisted, and if I execute the query doesn't use that query plan anymore. The query plan is changed. So SQL Server 2022 is identifying, using the history from query store, is identifying queries that could be improved by a specific change on their behavior, specific hints that could be applied to those queries, and it's applying those hints automatically, is not everything. These are specific situations, like the DOP situation, like the CE feedback that has specifically three three calculations being analyzed. And what happens with all these new incredible features is an important shift on many points. For example, in the past, uh, we have a query plan cache, and clear the query plan cache was always considered extremely dangerous, because if we clear the query plan cache, we will lose the current query plans for the queries. The queries will need to be recompiled again, and this is extremely dangerous. Before the queries are recompiled, usual recompilation time. This was the danger that we had before. But now, DOP feedback is revalidated. If we clear the query plan cache, the DOP feedbacks are revalidated. There is another feature that I haven't exposed today called PSP. This is completely lost if we clear the query plan cache. Uh, we would need a different session to talk about PSP. And about the query store. Before, if we clear the query store, we lose history. We lack some plain regression recognition, but that's it. But now, if we clear the query store, we lose the feedbacks, we lose DOP feedbacks, we lose memory grant feedbacks, we lose query store hints, and we lose CE feedbacks. So there is an important shift in relation to clearing these elements, clearing the plain cache, clearing the query store. There was one specific importance before, and now the importance is different. Some reference, Achieving Wonders with Query Store. It's a video on my YouTube channel. Query Store Hints, an article that I wrote in Redgate. There is the Bob Ward IQPU samples. Many of the examples that I made today are based on this GitHub from Bob Ward. And some time ago, it was December 2022, I organized a conference, Malta Query Optimization Conference, and I invited a series of speakers to talk each one about one of these specific features that I mentioned during the day, and each one complement and adding more to what the others have mentioned about the previous features. And all the videos from this conference are recorded and available on my YouTube channel. You can get a QR code and check the videos on this playlist. So, uh, thank you very much for watching. Thank you very much to be attending this session. I hope you all liked the session. Any questions? Anyone would like to ask anything?
Can you hear me?
Yes.
Yes.
Oh, all of a sudden it popped when I was trying to turn my camera back on. It was telling me I was having problems. That was awesome presentation. Thank you. A lot of great information for everyone to take away. All the beautiful pictures that you included were fantastic. Are those of Malta?
This is Malta. All the pictures were
Oh,
related to Malta.
they
Good
were
to visit, right?
beautiful.
Yes.
Beautiful,
Good place
beautiful.
to visit.
Yeah, I am especially excited at the beginning when you mentioned that query store will now be enabled by default, because I'm not necessarily a DBA, although I was in a previous life, but I am in charge of a lot of different production systems. So I think that's going to be a game changer for a lot of people to have that just kind of automatically defaulted. What
Exactly,
are
exactly.
with all
Yes.
these new features, what is the top thing you think people need to be aware of and watch out for?
Um, what I at the end call importance shift. How these new features shift the importance of things. Uh, how you see the clearing of the query plan cache before and after this feature, the impact is different. How you see the clearing of query store before and after these features, the impact is different. And I
Mhm.
would even add to that what the DBA should look for, because many people would complain about these features. Oh, but now the SQL Server is doing everything for me. No, it's not. Uh, it's not doing everything for you, but you need to look to different things. For example, DOP Feedback is doing a lot for you, but it reaches a point that you need to look what DOP feedback is doing, and that what the DOP feedback is doing will point you a bad configuration in your environment, like a bad max DOP or bad cost threshold of parallelism, for example. So what is happening will point for bad configurations in your environment. So
Mhm.
it turns the DBA job more specific. So it's a completely important shift of things.
Yep, yep, and with the cloud, that's super important to know how to shift anyway, so great stuff.
Yes.
Well, thank you very much. We really enjoyed it, and any last minute questions from anybody? Nope, I don't see any. Well, thank you again, Dennis. We really appreciate you spending the time, and I'll shoot you an email over when we put the video up.
Thank you very much. And see you soon on the next one.
Yep. Get some sleep.
Yes, sure. See you. Have a great evening. Bye.
Thank you,
Bye-bye.
Dennis. Bye.
Thanks.